Alright. It looks like it's going through. Let me just turn this down a tad. Got a new Java version. Okay, so let's just go ahead and get started with this. Welcome back to the OpenGL tutorial. This is our 9th episode, and today we're going to be looking at textures. So textures are not like the physical textures, but rather image textures, image files that OpenGL will place on the triangles so that you can view custom color values. For example, the reason why this is so important is because if you wanted to display, oh, that's loud, holy shit, I need to turn that down. Yeah, okay. Yeah, that's better now. So if we had like a very complex model and it had how many ever colors on it, like let's say it was this image right here. I actually need to download this, so let me actually download this stuff. There are 2 image files in the description. Go ahead and download them. But anyway, if you think about it, if you wanted to display each color and you didn't have textures to do that, you would have to define each pixel as a vertex and then just define its color, which would be enormously inefficient. Like the magnitude of inefficiency there is actually bullshit. So I'm just going to download these images and put them in the assets folder. I'm going to call it image1.jpg and then image2.jpg. Or image2.png rather. Okay, now we are good. Let's head back to the desktop. So yeah, it's what we're going to be doing today is we're going to be loading in textures, see how they work, and then we'll be passing them onto the GPU to display on our rectangle here. So first things first, let's go into the let's look at actually the vertices right now first. And then, you know what, rather let's do a little bit of cleanup first. Let's remove the transform from the vertex shader, just because I don't want to have it right now. Just like that, and then also remove the transform matrices in the main loop. Alright, just like that. So the first things first is I want to look at our vertex array. So I put the vertices back to just a rectangle. So if we display them right now, if I actually run this, I don't know if we'll get an error. It might be weird, but okay. So yeah, I changed some of the colors too. But yeah, this is what you'll get if you run it. So I just made it back into a rectangle. So what we're going to do now is we're going to look at how to actually pass a texture into this. So textures, we're going to have to load them in using the STB library, and we installed that in a previous video. I put the link down below. But it's not enough just to pass it in and then give it, let's say, a number. We're going to have to actually pass in texture coordinates that correspond to each vertex. So if we look at this image right here, for example, the bottom left of this texture would have coordinates of, let me just make sure I'm doing this right. It would have coordinates of 0, 0 in the texture coordinates. And we want to map 0, 0 to -1 on the polygon, or -0.5 on to the bottom left on the polygon. So here. So we're going to follow exactly what we have already been doing, and we're going to pass it in through the vertex buffer object. We're simply just going to add another attribute with some 2D coordinates, because the texture is only 2D at this point, and then that's how that's going to work. So just create a new kind of quote-unquote column for texture coordinates, and then just put for the bottom left 0.0, 0.0. For the top left, do 0.0 and 1.0. For the bottom right, do 1.0 and 0.0. And for the top right, do 1.0 and 1.0. So this will map the corresponding corners of the texture to the corresponding vertices. And once again, we do not need to change the index order because it is all the same. Now we need to create another attribute. So we're going to say here, for texture coordinates, we're going to say GL vertex attrib pointer. This is with the other attribute pointers. So this time it's going to be index 2 because this is our third attribute. The size is only going to be 2 because we're passing in 2 elements. Type is GL float. GL false for normalized. The stride this time is not going to be 6, it's going to be 8 because we have 8 elements per, or 8 floats per vertex. So the size in bytes will be 8 times the size of float, and you can also update that in the other attribute pointers too. So it should read 8 times the size of float for all 3 strides. And then the offset this time will be a void pointer of 6 times the size of float, because we have 2 3D vectors to go through before getting to the texture. So size of float. And then we got to enable it. So GL enable vertex attrib array 2. Just like that. Now let's look at how this will be received in the vertex shader. So underneath the other layout variables, just go ahead and add another layout. So layout location is equal to 2, this time because it's index 2. In vec2, since it's a 2D vector, a text chord. And since we don't want to set the color of the object in the vertex shader, we want to get the color from the image, and that will determine the color of the fragment. We want to pass this coordinate onto the fragment shader. So we're going to say out vec3 text chord, or vec2 text chord. And then in the main method, just say text chord is equal to a text chord. Just like that. And then in the fragment shader, we're going to do something a little weird here. So we're going to take in the texture coordinate, so in vec2 text chord, and then we're going to call a function here to set the fragment color. So you can comment that out, and then we're going to say here frag color is equal to texture, and then we have to get some ID from somewhere. So it's actually going to come in the form of a sampler 2D and a uniform variable. So uniform, so outside of the main loop we need to define another uniform variable. So uniform sampler 2D, this just tells OpenGL we're going to be passing in a texture ID, and it will map to a texture, and we want to sample coordinates from this texture. So we're going to give it a name, texture1. And then in frag color we say texture, just put in the texture value, so texture1, and the frag and the coordinates, so text chord. Now this will not do anything because we have not actually loaded in the texture. So in main.cpp, let's actually go ahead and do that. But the first thing is we need to include our library, which is stb image. So at the top, just go ahead and say include stb/stb image.h. Once again, I linked the installation of this library down below. Alright, so let's start by loading in just the first image, the Obama image. These are actually some quality fucking images, and we'll be blending them later on, and well, it'll be fun, don't worry. But my lord, look at that man just demolishing that ice cream. Doesn't he actually like really like ice cream? Obama ice cream. There's just so many images of him eating ice cream. Do you think he can I make this joke about the 44th president of the United States on stream? I feel so uncomfortable saying this. Do you think he eats at Michelle like that? That's the question. I mean, just look at that. God fucking damn it. Oh, I feel so fucking stupid saying that. Oh my god. But man, look at that. Slurping. 10 things Obama can teach us about eating ice cream. This is the Huffington Post, so I don't know what I can show you. Is this an okay article? Oh, look at that. Look at this, man. Oh, there's some shit on the side. I don't know if I can. There's some colorful ice cream. Classic. Traditional. That's a man who's satisfied with his ice cream. Okay, he's wearing his White Sox hat. Slurping that one. Shaking people's hands, probably with this sticky syrup on it. He's licking that one. Snow cone. Oh, he's about to fucking just munch on that one. And then he likes that ice cream and someone's taking a picture of him. Is that with his kid? That might be his kid. Obama eating shave ice. Alright, I'm done with this. We need to actually start writing code. Okay. Sorry about that. Okay, so let's do this. Underneath the vertex buffer object thing, we're gonna generate a texture. So textures, and like a lot of other things in OpenGL, it's gonna be represented using an unsigned integer. So unsigned int texture 1. So I will actually diagram out in OneNote how OpenGL represents this stuff. So what it has is, on the GPU, it's going to have a bunch of texture IDs. Oops. And you have your, I think it starts at 0, but you have your 0, 1, 2, and then blah, blah, blah. And they all map to some image. So, some maps to a stick figure. Another image maps to Obama. Third index maps to some other texture. Like that. And then we'll see how this is actually used to display, or how OpenGL actually finds that index and make sure that it's the proper, and make sure it's active when displaying. Alright, so to generate a texture, it's going to be pretty similar to the VBOs. GL gen textures 1, and then a reference to texture 1. Then we are going to bind the texture, so GL bind texture, GL texture 2D, and then the texture ID, so texture 1. Then we need to set some parameters here. So the first one is image wrap. So GL text parameter I. Then we set the target is GL texture 2D. The parameter name is GL texture wrap S. And the parameter we'll say is GL repeat. So S is equivalent to X, T is equivalent to Y, and R is equivalent to Z. But we don't need to know Z right now. So that's the wrap in the X direction. Then we want to say GL text parameter I, GL texture 2D, GL texture wrap T, and GL repeat. Then we're going to go through image filtering. So this is just essentially how OpenGL determines what pixel to actually display, or what color to display, because it can't display the top resolution, or because each decimal coordinate will not map to a specific pixel on the image. So it's going to have to interpolate, and there are several different ways to do that. There's nearest, there's linear interpolation, and there's a bunch of other ways that it does that. But for now, we're just going to keep it simple. We're going to say GL text parameter I for integer, GL texture 2D. The parameter name will be GL texture mag filter, and GL linear for the parameter. Then GL text parameter I, GL texture 2D, GL texture min filter, and GL nearest. So I linked down the text explanation with a bunch of these parameters on learnopengl.com. I recommend you go look at that if you want to play around with some of these. So now we're actually going to load the image. So int width, int and height, and number of channels. So the number of channels will correspond to RGB, which is 3, or RGBA, which is 4, or or just R, which is just 1 channel. So then we have to set, or let's just load the data. So unsigned char star data is equal to stbi, so the library load, and then we're going to say assets / image1.jpg, and then the other parameters are a reference to width, reference to height, a reference to end channels, and 0. Then we want to check to see if the data was actually loaded. So if data, then we want to set the data in the texture. So GL text image 2D, GL texture 2D. The level is 0. The internal format is GL RGB because it's a JPG. You can also determine what format to use with end channels. Then width, height, the border is 0. Format is GL RGB once again. The type is GL unsigned byte for the format, and pixels is data. So or unsigned byte here. So you might be wondering, well, why didn't you pass in texture 1? Well, because it's the currently bound texture. So OpenGL automatically knows, okay, I'm going to be setting this data for the currently bound texture. And then we want to generate something called a MIP map, which will also allow us for more interpolation and efficiency in image display. Essentially, MIP maps display or contain different resolutions of the texture. So if you're further away, it'll display a different resolution because you won't be able to tell different pixels apart from a certain distance. So then we just say GL generate MIP map GL texture 2D, and then else standard cout failed to load texture, standard end line. And then at the end we want to say stbi image free data. So then this just frees the data. Now what we have to say is we have to set this corresponding sampler value in the shader. So what we have to say here is shader.activate. Once again, you have to activate all your shaders before actually setting the value. And then you get to say shader.setInt. It's considered an integer. And just a quick note, I didn't have this explicitly in the last video, but in the GitHub commit I added a couple more of these uniform setting functions. So just go ahead and look at them on the GitHub, and it's pretty self-explanatory. So set the integer, the name will be texture1 as we denoted here, and the value will be 0. And you'll see why it's 0 and not texture1 in a second. So now in the main loop, what we have to say is, before I didn't completely explain how OpenGL renders textures. This is how OpenGL stores textures on the GPU. Now, for actually rendering the textures, OpenGL refers to something on the GPU called texture units. So texture units, and this is going to be like a 0, 1, 2, and ... How many ever texture units are available. And then what happens is, when we say the command gl active texture, and we pass in a 0 or something, what it tells OpenGL is this here, let me just grab a highlighter, is a currently active texture. So whatever is displayed, no, sorry, that's not true. This is the currently active texture. So whenever we bind some texture, it will map to a 0. So, or not that. So we activate texture unit 0. So once again, activate unit 0, and then we say gl bind texture as before. Then we pass in text 1. Whatever value text 1 has, if it's 2, this texture unit now points to the second ID, or the third ID, if this is text 1 here. So now when we render when we set that integer on the shader to 0, the shader looks for this texture unit. So in the shader, the sampler 2D values point to the texture units. So if we were to draw something now, it would display the dick and balls. Alright, so let's write this code out right now. So to actually do this, let's go right underneath where we clear the buffer bit. We're going to say gl active texture gl texture 0. So once again, this just activates the current unit, or the 0th unit. Then we bind the texture to the active unit. So gl bind texture, gl texture 2D, and texture 1. So it's essentially telling the 0th texture unit to point to texture 1, which points to the image data. So now you see how when we say gl text image 2D, it sets this data at whatever the active unit is pointing at. And currently, by default, the active unit is 0. So we don't need to explicitly say gl active texture, gl texture 0. Because what happens is, when we bind this texture to load data into it, it binds it at texture unit 0. So we load this data into the 0th texture unit, which passes it to the texture ID, which then points to the data in the GPU. So that's how that process kind of works there. And then everything else looks this right, so I believe we can just run this, and it might work. No guarantees. Fuck. Text chord, I misnamed something. Text chord. Oh, I miscapitalized. Okay. Now if I run it. And he's upside down. Oh, he's upside down. You wonder why. Well, this actually has to do with the JPG structure, just image file structure. STB loads the images in sequentially, but for some stupid ass reason, all images are stored upside down. So we need to tell STB to flip the image, because we don't want upside down Obama. If Obama is upside down, that's just wrong. So it's a simple command here, just to say STBI set flip vertically on load true, And now Obama will be upside right. And voila, perfect. Look at that. Now let's try doing something really cool here. Let's say text chord is equal to a text chord dot yx. So once again, the versatility of the shaders here is shown in its full form. We can take the y and then x, and we can output it as a 2D vector. So let's see what this does. He's now sideways. Sideways Obama, and he's also inverted. So it's just cool stuff that you can play around with, because you can just access individual components of the vector and then pass it in somewhere else. So that was sideways Obama, right? And now let's try incorporating that with a second texture here. So let's try doing a second texture. So it's going to be pretty simple now. We just have to create another unsigned integer, so texture 2. And then underneath here, underneath where we free the data, let's say GL gen textures 1, and then a reference to texture 2. Then GL bind texture, GL texture 2D, and texture 2. And then we load the image data once again. So data is equal to stbi underscore load assets slash image2.png. And then we have a reference to width, reference to height, reference to end channels, and then it's 0 there. Now here in if data, we're going to see something weird here. So same thing, so GL text image 2D, GL texture 2D, 0. Now the format is going to be different. PNGs have a layer of transparency to them. They have a fourth component called alpha. So for the internal format, we have to say GL RGBA. Then the width is the same, height is the same, border 0, format is GL RGBA again. Type is, what is the type? GL unsigned byte. And then data. Then GL generate bitmap, GL texture 2D. And then else we can say failed to load texture. And then we say free the image data again, so stbi image free data. And then we want to set the image value in the shader, so shader.setInt texture 2, and then 1 this time. And then in the main loop, we have to correspond it to that, so GL active texture, GL texture 1 this time. What does that expand to actually? Oh, I don't know. And then we have to bind the texture, so GL bind texture, GL texture 2D, and texture 2. Alright, now we can go into the fragment shader. And then we're going to say uniform sampler 2D texture 2. And we can use a function that is, or you know what, let's actually, I'm sorry, I forgot to do something. Let's try doing something cool with this texture color here. We have a vector our color here. Let's try multiplying the two. So our color, of a 4D vector of our color and 1.0 times the texture. Because this color is normalized, it's going to be from 0 to 1, so it won't make the texture colors more than 255, but also this will take the dot product between the two colors, because this essentially just multiplies each component individually and then puts it back. So if we run this now, what happened? Oh, it's the fucking image. Oh, this asshole. Where? Oh my god, I remember this. 1 second. This stupid image, for some silly ass reason, is broken. Like the American flag. I don't know why. But it's a perfectly good American flag. And it loads on paint. So now we have to find another American flag. I mean, let me try try saving it and see if that works. Nope. Okay. So the image is just fucked up. Alright, we need to find a replacement here. Alright. Let's go. American flag PNG. Where is it? That looks like dog shit. Here we go. This, oh my god. Look at how just fucking absurd that looks. Alright, let me just save this real quick. Oh my god, that looks like dog shit. That is fucking, like, that is actually fucking sacrilegious right there. Alright, well, you got what you wanted, let's load this. Oh my god, okay, wait, it's still Obama, it's okay, guys. But you see how the colors kind of had an effect on what we actually wanted to do. So by taking the dot product of two colors, you get a mix of the colors, kind of. Not really a mix, but you kind of just multiply them together. Now let's try incorporating that second texture using the mix function. So OpenGL has the shaders have a built-in mix function that kind of combines two colors and I guess takes a weighted average of them. So we're going to say frag color is equal to mix of texture 1 and text chord, and then texture 2 and text chord, same texture coordinates, and then we have to specify a factor, so we're going to say 0.5. And oh my Jesus Christ. Oh my god, that's just so sacrilegious. Like, I'm not even kidding. What the fuck? That actually just hurts to look at. That flag is, it's like, it's just, what the fuck? But why, like, why would that happen? Why would somebody think that it was okay to make an American flag like this? Like, what the fuck? What's up with the stars? Is this even 50 stars? 1, 2, 3, 4, 5, 6, 7, 8, 9, what? 9? Oh my god, what the fuck? What the fuck is this? Why are there just fucking straight up sacrilegious fucking flags? This is, that's right. That's an American flag right there. What the fuck is this? What the fuck? Oh my god, the people who made these should just all actually just be shot. Axe equipment, quality and efficiency, go fuck yourself. Where do you, Council Grove, Kansas? What the fuck? This looks like, okay, that's a nice car, but still, that looks like straight up stock images. These two look like they're having a fun ass time, but like, Danny? You guys know Danny? But like, holy shit, you guys can do better than that silly ass American flag up here. Like, come on. Like, bro, that's just, oh, did I just say bro? God damn it. This is just bullshit. You're giving me a silly ass gallery. Though these are some nice cars, I won't lie. Hooters. Nice. Okay. So yeah, I think we're good there. So I will just do a quick recap of. I am down from my nationalistic pride high, and I have calmed down, and I will now go back to OneNote, and I'll explain. I'll go back through the process of this in terms of the GPU memory. Alright, so let's take the two images and we will put them in OpenGL, or not in OpenGL, in here. Alright, let me just find them. Oh. So image 1.jpg and image 2.jpg. Alright, so we got a cursed American flag that is actually like just fucked up, and then we have Obama eating ice cream. So these two images just exist on the computer. They're not in the memory yet. When we start the program, we go and so let's look at the so on the GPU we have our texture units. So 0, 1, 2, ... and then we have our just textures. So in the code, I'm gonna just color code this kind of. So we have, alright, so I'll say green is just the entry. So main, whatever, blah, blah, blah. And then what this corresponds to is just the default texture 0 being activated. No textures have been loaded yet. Then when we want to say, first thing we do with the textures is we go ahead and generate them. So where is it? Here we go. So gen text1. What this does is it generates an ID, so I'll call it ID 0. It has some integer value, and the active unit now points to ID 0 when we, or no, not yet. Sorry. Then we want to say bind text1. Now the active unit points to 0, or the first ID. Then we set the data. So I'll do this in blue. So load. So what happens now is the first image that we loaded in, the Obama image, is now loaded into the GPU memory somewhere, and ID 0 now points to it. And then we do something similar for texture 2. So gen text 2. This now creates an ID 2. Or ID 1, sorry. And then we say bind ID, or text 2. Wait, no, I'm sorry. I should be naming these the same, because they're the same same value. So yeah. So purple. So now we say bind text2. And what this does now is destroys this pointer, and then it just now points to texture 2. One second. And then after that, we go to these shaders, and then we have to load the data. So I'll do this in brown. So this now points to the American flag, the cursed one. I actually need to update the image link on the, yeah, let me do that real quick, just so you guys don't download the wrong image. Where is it? Come on, Danny, give me your image. Here it is. There we go. There we go. Perfect. Edit title and description. Image 2. There we go. Alright, save. Alright, so the image should now be, or the link should be updated. Alright, so now that we have this kind of structure here, we now say shader.set either uniform values, so I'll do this in another green, so blah blah blah, 0 and then 1. So in our shaders, we have our uniform 2D texture 1 and texture 2. So by setting these two to 0 and 1, we now point texture 1 to 0 and texture 2 to 1, like so. Or let me actually just bring it around. Like so, and that's just set in stone. Now in the main loop, we now say, or let me actually just wait. You know, I'll just do it in black. So in the main loop, what we say is, what did we say? I'm running out of colors here. So the first line is active texture, texture 0. So this makes, once again, this one active. And we bind it so it still points to texture 1. The reason why we have to explicitly bind it every time is because when we have a larger program with more textures, we don't want to have all the textures loaded in at once, or pointed to at once, so we need to kind of cycle through them. So active text 0, and then bind text 1. This then points to there. Then we say, where's another color here? Let's get a nice shit color in here, like that. Oh, that's a nice brown. Yep, okay. So then active text 1. Then we make this one active. So let me, is there a way to highlight that actually? Oh, there is, oh, there, there we, oh my fucking lord, perfect. So now this is the active texture. And then when we say bind text 2, we tell this one to bind to texture 2. And that also deactivates texture unit 0. I also forgot to say that when we bind the gray here, so in the main loop when we bind texture 1 for the first time, what that does is that destroys the link from texture unit 0 to texture 2. So yeah, that's how that kind of pathway works. So yeah, we can play around with this, I guess, for a bit. Let's split up Obama, or you know what? Yes, let's split up Obama. So let's go back to just having the single texture in the fragment shader. So we'll just say right here, and then I'll return to the or I'll re-implement the transformation. Like here, and then I want to set that transformation matrix again, or both of them rather, because we're gonna have two. So, oh wait, did I? Oh yeah. Oh damn it. Okay. So yeah, I got rid of the second shader in here, but I mean, we can see rotating Obama. That's fine. It's actually not going to, because we didn't even set the fucking matrix. Okay. Wait, isn't this doing it right? Oh, because you don't even draw it, that's why. Okay, now it should be rotated. There, and it is rotated. So let's do this. Let's make him rotate over time. There we go. And Obama is now rotating over time. And that looks kind of weird. And you know why? Because the axis that we actually rotate on here is bullshit. This is on a non-z-axis axis. So it's going to rotate around that, and the z coordinates are going to change. Now if I change this back to just 0.0f, 0.0f, and then 1.0f, what it's going to do is it will just rotate around the z-axis. We'll get more into transformations once we get into 3D space in a bit. Yeah, Obama's now rotating. Look at that. You can see him from all angles. Yeah, I don't want to waste any more time. This is pretty much all I wanted to do in this video. And the next one, I actually didn't prepare this, but I'll be posting a 5-minute video which integrates keyboard input into with shaders and textures, and we will see how that works. And then what's the next one? 11 is, it might be 3D. Let me actually just check real quick. He's getting faster. 11 is advanced. Alright, so we're going to be looking into a more formal I/O system with arrays for the input values, and we'll see how that works. So yeah, that's to look forward to. And then we will get into 3D spaces, cameras, lighting, and then object loading after that. And yeah, so until I might even do this tomorrow, to be honest, because I want to get this stuff, the redoing of these streams, over with, so I can get back to what we were currently on. But in any case, hope you guys enjoy spinning Obama, please. Don't spin him too fast, because he'll drop his ice cream. And then, yep, just enjoy yourselves, stay safe, wear masks. Don't eat anyone's ass that you don't know, at least. And then yeah, until next time, I will see you then. Adios.